Welcome back. We finished on a note wherein we learned how you could create pull request, wherein you were kind of working on your own branch and you want to make sure that you want to get your code changes reviewed by someone else. We also learned how you could migrate your repo from GitHub, or existing GitHub repo to Azure DevOps, which is pretty simple and quick. Within a few seconds, we were able to migrate. In life of DevOps engineer, continuous integration and delivery is a very important skills to learn, whether you're working for an infrastructure or you're working for an application, be it Node.js, .NET, Java, Python, Ruby, Go. You got to know how you could create a CI and a CD pipeline. Majority of the CI tools nowadays, be it GitHub, GitLab, TeamCD, Octopus, Jenkins, majority of them supports the pipeline, be it in the YAML or any other. Majority of the cases is going to be YAML. However, Azure DevOps not only gives you YAML but also gives you uh, a GUI to perform the CI. For those folks who are new to CI, it's a process wherein you build your code whenever a developer check in or commit their code. Your pipeline should be automatically built and test the code so that it can be shipped or deployed onto different environment, be it the containerized application like Kubernetes, Docker, or a virtual machine or a physical server. Your pipeline should be powerful enough to detect any changes automatically and then start building the code with all the dependencies. That's what we're going to do. We don't want to manually build or deploy code from our machine. What we want is we want a CI process which detects the changes automatically whenever somebody pushes the code and then builds it. I've already got a repo which is uh, Terraform Azure. I have the repo on to my Azure DevOps right over here. I've already cloned it and take the latest pull. It has got bunch of Terraform file which creates bunch of resources. What I'm going to do is just going to do a Terraform plan and it's going to show you what it's going to build. Now this is going to build resource group around 21 resources, then the storage account, DNS, network security groups, and if you see over here that it's going to build 21 resources for us. Now you could apply it and this is going to create infrastructure onto Azure, but this is being created locally onto your system. Now you don't want to do that. You don't want a system specific environment. Now this might work on your system, but it might not work onto other system. Now what happens with the centrally managed system, everyone kind of can deploy the infrastructure or application from the central managed server. That's what we're going to do rather than installing all the dependencies onto your machines. Now let's suppose I've seen many of the companies doing these mistakes wherein whenever they want to deploy the infrastructure, what they do is let's suppose there are 5 members in the team and each of them gets to deploy the infrastructure for different clients. What they generally have seen people doing is start installing the dependencies onto the local system and then they spend half a day, sometimes more than that, just configuring their system, maybe installing the latest version of Python, Terraform, and then maybe some fixing some issues around the networks or VPC. Uh, However, if you replace this with a centralized server, everybody can use that same server to deploy the infrastructure, and that's one of the key benefits you get when you perform CI/CD using the central server rather than doing it from your local system. So what we're gonna do is we're gonna create the CI pipeline. For that, you go to the pipeline right over here. You click on create pipeline and then you get started by so it asks you whether you want to create using YAML or the classic editor. Classic editor, those who are not very familiar or comfortable using YAML can use the GUI. Don't worry, we're going to learn how to configure pipeline using YAML as well. Then first thing first, you got to have a source code somewhere sitting, maybe Azure DevOps, Azure Repo, GitHub, or Bitbucket, or any other version of Git. For our purpose, we're going to use the Azure repo because that's where our code is sitting. Select the project, select the repo, and then the branch which you want to configure the CI for. I have only one branch at the moment, which is master, and that's what I'm going to configure the CI for. I'm going to hit on continue, and then I'm going to select the empty job. As soon as you do it, you uh, get asked to give it a name. I'm going to give it a continuous integration. Make sure I put the right spelling, and then you use the pool is the agent pool. Underneath you get to select virtual machines. Now these machines are where your build runs. Now to run a build, to ship your code or to build your code first, you need to have a virtual machine, you need to have a host. So Azure DevOps gives you by default machines, and when you sign up for the free account, you get 1800 build minutes per month. Also, you could use your own virtual machine as well. However, if you don't want to manage those sort of virtual machines, Azure manages for you, and you could use it free of cost. So I'm going to use the Ubuntu at the moment, and then I'm gonna hit on the add task. Now these are tasks by default Azure DevOps gives you so that you could use it for your project. Maybe you're working for Azure or a bash script or anything else. Azure gives you all those features by default so that you don't have to write anything from the scratch. There's already tool available. You don't have to rebuild the wheel again. There's something already available. You could always leverage that, rather focus on your product, and then rather than building these CI tasks. So these are available free of task. Few of them are not free, but majority of them are, which actually makes the job. It's not only limited to .NET or Azure DevOps or Azure. It also works for any other third-party tool as well, be it Docker, Go, Grunt, Jenkins, Maven, MS Build, SonarQube. If you're working on iOS application, you could Xamarin as well. For our purpose, what we're gonna do is we need Terraform task, and I'm going to use the installer first so that it can install the Terraform, and then you can type in the version right over here, and then the control option gives you whether you want to enable this task or not. Obviously I want to enable it. Continue an error is a feature wherein you want Azure DevOps to skip it to the next one even if the previous one has failed. We're not going to do that. I'm going to use the Terraform again, do a Terraform init, add this task, select the provider. I'm going to rename this as init, provider as Azure. Had it been AWS or GCP, we would have selected that. For now, I'm going to select Azure RM, and then the default working directory. Azure DevOps gives you by default variables. For now, we're going to use the by default variable system.default working directory where all our code is sitting. And then we're going to use the subscription, which is Azure subscription one, and as soon as you do that, it's going to list down all the resource group you have. I already have an Azure DevOps resource group, so we've got the resource group. As soon as you select the resource group, it's going to list down the storage account as well. If you go to Azure, you would see that you have got the Azure DevOps Shan storage account, and then you get to select the storage account. And then the container, I guess we haven't got any containers, so probably we'll create that one. Go to container and just create a container blob. Alright, so you select the container name and then the key. So you use the key right from here, access key. Keep it very secretive because that gives access to your storage account. And then we probably going to use another task, which is Terraform plan. So we are going to go to the plan and select the plan and use the subscription, and that's pretty much all. So we've done the inet and plan, what we generally do from the local system. So idea is to just replicate what you do generally in the local system and then package it so that this can be shipped onto a different environment. And then the last step we do is add another one and use this as artifact. So artifact as nothing but a packaged published build artifact. So this gonna be the package of your code, which we are going to use, and we are going to use the system.default working directory. And yeah, that's pretty much all. We are going to hit on save and queue, so that's start building the code for us. Hit the run button, it's going to start building the pipeline. If you click on the pipeline, you're going to see the step gonna start running one by one, all the steps you've given. So it's going to start initializing the job, then it install the Terraform for us as per our task. Then it does the Terraform init, which is the initialization. It is just completed the init, then it does the Terraform plan, and you see that plan gives you all the 21 resource it wants to create, similar to what we had locally. And then it drops the package. It packages it in the form of an artifact so that it can be used to deploy onto some real environment. So you've got the artifact. As I told you, artifact are nothing but the packaged code. So you've got the code right over here, which can be used to deploy onto environment. And then yeah, you have got your first pipeline ready. So if you go ahead and download the logs, add or edit the pipeline as well. If you go to the settings again, you could see the triggers. Now you haven't got the continuous integration enabled. What it means is whenever the developer commits any code, pushes a new code, it won't be triggered automatically. So you could enable it, and we're gonna see how you could the code, whenever somebody pushes the code, Azure Devops gonna automatically build it for you. Then you've got the schedule as well. Schedules are nothing but you could if you want the builds to be triggered again and again every day, at some point of time you want every Monday a new build should be deployed, you could just automatically set that up. What I'm gonna do is I'm just gonna hit save, and what I'm gonna do is I'm gonna pull up my repo, make some changes, probably add a comment. um, Testing continuous integration. Now we haven't got any pipeline running at the moment, just to show you, nothing running right over here. If you do a git status, we've got one change, git add, git commit -m, added ci test, git push. As soon as you push the changes, you would notice that once the changes are being pushed, Azure DevOps has picked up the automatically changes with the comment. That was the latest comment we made, and it started building and completed the CI for us. Now this artifact is ready to go onto any environment we wish to ship this into. Alright, that was about continuous integration. I hope this was informative. I'll see you in a while with continuous delivery. Thank you.